Welcome to doassignment-ca. Here's the problem. The velocity of a car is plotted as a VT graph. From t equals 0 to t equals 40 seconds, the velocity is constant at v equals 10 meters per second. From t equals 40 seconds to t equals 80 seconds, the velocity decreases linearly from 10 meters per second to 0 meters per second. Determine the total distance the car travels until it stops at t equals 80 seconds and construct the AT graph. Now let us work through the solution step by step. Looking at the VT graph, we can identify two phases. In phase 1, from 0 to 40 seconds, the velocity is constant at 10 meters per second. In phase 2, from 40 to 80 seconds, the velocity drops linearly from 10 meters per second down to 0. Acceleration equals the slope of the VT graph. In phase 1, the velocity does not change, so the acceleration is 0. In phase 2, the velocity drops by 10 meters per second over 40 seconds, giving a constant deceleration of negative 0.25 meters per second squared. The AT graph is a step function. It sits at 0 from t equals 0 to t equals 40 seconds, then jumps down to negative 0.25 meters per second squared, and stays there until t equals 80 seconds. The distance in phase 1 is the area of the rectangle under the VT curve. That is 10 meters per second multiplied by 40 seconds, which equals 400 meters. The distance in phase 2 is the area of the triangle under the VT curve. 1/2 times 40 seconds times 10 meters per second gives 200 meters. We can verify this using the kinematic equation, which also yields 200 meters. Adding the two distances together, 400 meters plus 200 meters gives a total distance of 600 meters. That is the total distance the car travels before it comes to a stop at t equals 80 seconds. Visit doassignment.ca for more study tools, AI learning support, and online tutoring.